Hey everybody. This video is going to be about a concept called multi-threading. Now, what multi-threading is the ability of your program to do lots of things at the same time. This is sort of analogous to multi-programming, or multiprocessing, which is where you have your different programs running at the same time. Like you've got Firefox running at the same time as you've got Eclipse, and these programs can both be doing stuff at the same time, right? Now, multi-threading is similar, except that it's when this happens within a single program. Now, there's lots of reasons you might want to do this. You could picture that, for instance, in a game, you might want the music to happen at the same time as the graphics are being updated, and perhaps even at the same time as the physics is being updated. And so you can make these sort of multiple sub-programs or threads that all happen simultaneously. Okay. Another common example is when you do networking. So, if you've got a program that does some internet requests, like Eclipse, for instance, updates itself in the background. It's kind of annoying, but it does it anyway. And you'll notice that although it's updating in the background, I'm still able to click on things. I'm still able to type. I'm still able to autocomplete. And that means the program is capable of doing multiple things at the same time. The mechanism by which it can do that is multi-threading. Okay, so in a normal program, you've just got sequential execution. So you've got a main method, and in it, you've got some stuff that can do some commands, right? So let's say I just had some commands in here. If I ran this, it would just execute the commands sequentially. First this one, then this one, then this one, then this one, then this one. Okay, so nothing's happening simultaneously, if I can put it that way. There's just one execution line happening, right? Now, with multi-threading, what happens is that I can create a sub-program. In Java, this is accomplished using the thread class. Okay, so if I want to do that, I can make a new thread, which is a new one of these sub-programs. It's a thread t equals new thread. Now, I've fundamentally got another program that'll run at the same time as the rest of this main method, right? But how do I define what it does? What I do is I create a new runnable. Runnable is an interface, and if you guys remember from the lectures we used to do in class, all an interface is a contract that forces us to define a particular set of methods. Okay, in this case, our runnable forces us to define a run method. Okay, and the run method is a specification for what this thread is going to do. So maybe I just want to write a for loop, and so I'm going to say, let's make a random for loop there, 10, I don't know, and I'm going to print out maybe x. Okay, and when I make the thread, then I can pass in the runnable r. Right, now the thread knows that because this is a runnable, it must have a run method. So that means this thread, this separate program, knows that this is the piece of code to execute. Okay, so I then call the start method on the thread, which is a predefined method that will create this the thread and run the run method in a separate execution line, basically. Okay, then I'm going to change this main program, and maybe I'll just write another for loop here. It's less than 10, and let's on this one print out dots. Okay, now if this program were executing in a traditional manner, you'd expect that all of this would run, so you'd get 10 x's, and then all of this would run, so you'd get 10 dots. Okay, when I run it, I mean, you'll see I actually got 10 dots first, and then I got 10 x's, which is a little weird. What's even weirder is that if I run it over and over again, I might get different results. See, look, this time I got like 7. I got 7 dots, and then 10 x's, and then 3 dots. That's incredibly weird. If I make this like 100, and I run it again, see like there's just some X's, some dots, some X's, and it's not really clear how many you're going to get. It's pretty random. So the scheduling of these threads is not up to you, it's up to the operating system. Okay, it'll decide, hey, the guy that's printing out X's hasn't had enough of the CPU, he hasn't had enough time in the sun, so I'm gonna let him execute. And then at some point later it's gonna go, yeah, but this dot guy, he needs some love, I'm gonna let him execute for a while. So the let's put a print line just so it looks a bit neater. So you'll see like every time a dot prints out and then every time X prints out, it's just random. There's no clear guideline on which will run first, although they do seem to be happening in not entirely unpredictable. But look, I mean, I'm running it over and over again. I'm getting different sequences of X's and dots. Okay. Now, I can make as many threads as my operating system will allow. So I could just make a whole nother thread. And if I use the same runnable, then this thread will also be printing out X's. And so now I'll have 2 threads printing out X's and 1 printing out dots. So I'll get a lot more X's than dots. I can create another runnable. Maybe this one will print out pluses. I'm not being particularly inventive today, am I? But anyway, now you'll have 3 things, 1 printing out X's, 1 printing out pluses, 1 printing out dots, and you just can't predict what will happen. There's X's, then pluses, then dots, then pluses, and it's random. But the cool thing about this is all these things are running at the same time. None of them is waiting for the other one to happen. When you wrote a sequential program, each instruction could only execute when the one before it had finished, right? In this paradigm, that's not the case. So like I said, this is very useful for things like network requests, and you've already seen it in your OKHTTP lab. One thing you have to be careful about is because instructions don't have to wait for the ones that are before them, you can't rely on those instructions having executed. Okay, so let's use a different method for creating a thread. There's lots of different ways of doing things. In this case, I'm going to make a new class. I'm going to call it updater, and its job is going to be to update some variable for me, right? But I'm going to extend thread because I want it to run as a separate program. Okay, now threads have got a run method, and so this is just a specification for what I want to do in it, right? So for the moment, just for testing, maybe I'll make it print out copy characters. Okay, now get rid of all of these threads, and I'm just going to say updater u equals new updater and u.start. Okay, that's going to accomplish pretty much the same thing I had before, right? I've got okay, this shouldn't have been a print line, it should be a print. I've got some code executing intermittently, and you know, it's just this one only prints out 1 copy, right? What's interesting is you'll see the position of the copy moves because, you know, again, I don't know when this function will execute. It looks kind of regular, but it does move around. Okay, so now let's say the job of this updater was to update some variable. So let's say I had some array. Let's say int array values equals new int array 100 or something. Okay, and you know, Java initializes this to 0. So let's system.out print values of 0. Okay, so it's going to print out the first item in the values array. Okay, so if you look at it, you'll see that it's going to print out zeros because there's nothing really in there. Okay, what I want the updater to do is to change the value of that integer. So the first thing that comes up is that I need the updater to have that array so that it can update it. Okay, so what I'm going to do is in the updater, I'm going to make a constructor. And I'm going to use it to set some internal variable. Okay, let's not complicate matters. Let's say array equals error. So what happens now is I can, in my program, set the constructor parameter to values, right? What that means is I'm creating a new updater with the parameter values. What's going to happen in this code here is then values is going to be this ARR parameter. It's going to be copied into the field, the object's value called array. Okay, so the effect of all that plumbing is that this array is equal to this array, right? They're the same array. It's not that it's a copy, it's literally the exact array, because Java is passing the memory address, not the values in the array. Okay, so let's say the purpose of the updater was to change the value of the first item. Let's say I said array of naught equals to 10. Okay, so it's just updating the value of the first item. If I said if 11, okay, maybe not 10 because 10 prints out funny. Let's make it 4. Okay, so I've got a 0 and then a bunch of 4s. Okay, but if I run it over and over again, it's not clear that I necessarily will always have that value, right? So I'm just going to put in a dot because I want to see where the thing, at what point the thing updated. So you see, it updated at some random point where that dot happened, you know, and then there's one more 0 and then 4s basically, and it just keeps changing. Now in a sequential program, I would have said, well, after I call u.start, I would expect this thing to have happened. So let's say I didn't have a for loop, I could just print out values of naught, and I would expect it to have changed because I created the thread, I ran it, but when I do it, I get 0. But I won't always get 0, right? Sometimes I might get a 4. Okay, so this is because the two programs actually just run independently. Okay, in this case, I'm not getting lucky enough to see a 4 there, but the point is, I can't tell at what point. So if you just print it out over and over again, at some point, it'll update and get 4s, but early on it didn't. And it's not clear which one is going to happen first. Okay, so I can't rely on sequential execution. Now you'll notice in the next lecture that does the networking stuff, we use what's called a callback. And a callback is a function that runs when a particular thread finishes executing. So it kind of triggers the program to do some other thing. And this is important because let's say I had a thread that had to go and get a value from the network. Okay, so it's equivalent to this updater method. And then I want to take that value and do something with it, potentially print it out like this does, right? I can't just tell my one thread to go get the network value and then straight after that use it, because it's multi-threaded, right? It doesn't execute sequentially. This is a good analogy for this is, let's say I had a whiteboard in front of the class and I had 2 students, and I said to the one student, walk up to the board and write your name on it. And I said to the other student, look, right now, read what's on the board. The second student wouldn't be able to read the first student's name because he hadn't gotten there yet. So the thing with, like, for instance, a network request is it's really slow, right? So that's equivalent to the student that's writing on the board, writing incredibly slowly. And then the student that's reading from the board is reading immediately. And so when the student that's reading reads, the student that's writing hasn't written yet. So the student that's reading is reading nothing. Okay. This is called a race condition, and it basically says whichever thread happens to be faster just by luck will modify a value or not modify a value, and the output of the program will be indeterminate because we can't tell beforehand which thread is going to end up being faster. Okay, so how we overcome this race condition in a lot of languages is we use a callback, and the callback is basically the guy that's writing his name, he'll just tell you when he's finished. So he'll write his name and he'll say, I'm finished. And then the second guy can read it at that point. Okay, I don't know if that made any sense, but hopefully it will when you watch the networking video and you see the callback that happens when the network thread is done. and wants the user interface thread to actually do an update. Okay, thank you all for listening.